Okay, let me share my screen real quick and we'll take a look at the. So I've shared the image. You should get it maybe sometime this week, the next week. Okay, maybe on Monday or Tuesday. The ASA image, and then I'll have them upload the image to the racks as well, so that if anyone does not have the resources to run their own Eve instance, they can still use the rack. Okay.
Sorry, I missed this. So you already uploaded your image, right?
I've uploaded the image to cloud. I've shared the link to be shared with you guys. Okay, so it should be shared by the team maybe tomorrow or day after tomorrow. Okay, because since it's weekend. Okay, so it should be shared by then, and then I'll also have the image uploaded to the rack servers as well. Okay, so if someone cannot run the lab locally, they can still access the rack server.
Okay. Actually, I was reviewing the last video which was uploaded. I think it was 26 June something. But the font was very, it is very small, and I was not able to see any configuration. So that was a worry. Means I understood the concept, but the configuration I did not see clearly anything.
Yeah, they actually told me in last weekend as well. So last weekend I tried to do the configuration through the PuTTY session. Okay, so the previous videos, initial videos, it might be a problem. It should not be. So make sure you're viewing it in the highest quality. So before this, I have never had anyone complain about the small being the font being small. So make sure you're viewing it in the best quality, 1080p to be precise.
Okay, so are you saying that like the video is uploaded in a portal site and we are looking from there? So are you saying there is some setting so we can modify this quality, something like the way it is on YouTube, something we can change.
Right. So you don't have any such option?
No, we don't have any options to change because it's online. We have to watch it.
Yeah, really.
Okay.
Yeah. That is the scene actually.
Okay. Okay. I'll ask the team once if there's a way to improve the quality or maybe have another way to view those videos. And let me know if any of the configurations is not clear or anything. We can talk over it, go over it again if need be.
Yes. Okay. I got it. So yeah, so actually I was trying to do a basic setup, like the way I asked you query about the inside and outside, and the same I asked you also
Right.
Kartin. But again, so I'm not able to see. I'm not able to share my screen. So that was the thing. So some doubt was there because I need to do a lab, but I'm still stuck in the basic. So I tried to view the configuration in your portal video, but that was not also always because the font was very small. So I stuck and I left there as it is.
Okay.
Yes.
Let me. Okay. So I'll ask the team to maybe give you access to the recordings for the ASA initial recordings for the March batch that I started. So there you should be able to view the recordings, I used my lab at that point. So the CLI and configuration should be better that way. Okay. So let me just ask the team to give you access to the March batch ASA videos. That way you can at least have that. And then moving forward, I'll probably take care of that part to not, to make sure the font is big enough.
Okay. Thank you.
Yeah, please provide us as well, sir.
Yeah, I'll ask the team to provide everyone on here access to the March videos for the ASA, at least the starting videos. Okay.
Okay.
Okay. So we'll use this topology. It is the same topology that you have on the servers as well. Okay. And if you want to replicate this in your lab, then you can do it. So this part here we'll use for the failover, okay, for security context and for the active-active failover. And then this part here I'll show you for the clustering, okay. Let me see if these are up and running. Three 706. Okay, so font should be much better now. Should be able to view the font properly as well.
Yes, it looks good now. I think.
Right. Okay. So coming back on the topology, so we'll be using this to do first. We'll cover our security context. Okay, and I talked about this yesterday as well. The topology, I'll just go over it again. This is the same thing here. This is where we're gonna set up our security context. Okay. This interface here, Ethernet 0, it'll be shared between context 1 and context 2. And then this will be an inside interface or an interface that will be assigned to context 1. This will be assigned to context 2. Okay. And then I'll show you the problem that we get with the shared interface as well. And then how does the MAC addressing and everything is changed. Okay. So nothing too complex. It's just to understand how the contexts work and everything. And once it works, and if the contexts are in place, it's just basically your regular ASA firewall. So all the commands that you run on this physical device, you then run on these individual contexts. Word for word, there is no difference in the commands and everything. Okay. So let me just first configure the IP address on the router. Just okay, that's all that we need on the router. There's nothing much to do from the router's perspective. We'll set up the firewall. Okay. So when you do a show mode, by default, it is in a single context mode. Okay, which means that I cannot do any context. So if I try and run the context command, it basically will not recognize that command currently. Okay, and this image here, this is basically simulating or emulating a hardware. Okay, so it is emulating a hardware chassis. So even though it is running virtually, this device thinks that it is running on an ASA 5520 chassis. Okay, And the difference, if I spin up an ASA virtual image, okay, so let it boot in the meantime. Okay, so this chassis thinks, or this device thinks that it's a ASA 5520 chassis. Okay, if I come down here, we look at the licensing, and you can see security context is enabled, and it has a 20 security context license, and it's valid for 364 days. So if you're going to see the rest of them are perpetual licenses. Okay, and when I say perpetual, I mean that they won't expire. Okay, they're permanent. Security context are added on top. Okay, something like an add-on or an you purchase them separately, right? So that's why you have a validity for them, which is 1 year. Okay, and you can see everywhere this basically chassis thinks that it's a hardware device. Okay, and the reason for using this image is, again, you cannot do security context on virtual images. Okay, because the whole premise of using security context is to have virtualization. When we are running virtual ASA images, we are already running virtualized instances. So you do not have to pay any money to run instances, right? So I can run 10 virtual machines without having to pay anything. But if I purchase 10 hardware chassis, that is going to be a significant cost. Okay. Yes, they do get licensed. Okay, they do have licensing, but then again, you only pay for the licensing. Okay, so that's why the concept of virtualization is only for your hardware chassis and not for your already virtualized instances. Okay, so things like our security context, things like our clustering, things like our active-active failover, right? If you remember active-active failover, it also uses security context. So again, we cannot use it on the virtual ASA. Okay, you can only do it on hardware chassis. Clustering is another feature that does not work on virtual instances. It is only supported on hardware chassis. And it's the same with your firewall as well. Sorry, the next generation firewall as well. Okay, so clustering is not supported when you're doing something virtual. Okay. Okay, so this guy booted. If I do show version, this is basically a ASAV. It's a virtual instance. Okay, and this is basically a hardware instance. So that's basically a difference. Okay, so this is what I was trying to run yesterday on the rack servers. Okay, and it did not work. So I am running this 915. The racks also have 915, but when I run this, the interfaces don't get initialized. Okay, so basically I don't see any interfaces at all. Okay, so that was one of the problems. And then a couple of images were also there. There was one for 914. There was one, I guess, 911. Those were basically just crashing. Okay, so this is image that I typically use for these sort of tasks, and it works perfectly fine. Okay, virtual images, you can use anything. Okay, so I'm running quite a recent one, 914. Okay, and this is what we did, maximum number of labs for ASA. Okay, so everything except for security context and beyond. Okay, security context, active-active failover, clustering. Those are the only 3 things that you won't be able to test with the virtual image. Apart from that, everything related to ASA can be done using this. Okay, that accounts for about 85% of what ASA has to offer. Okay. So let's remove this. Let's come back in here. So now, the first thing is to change the context, and we do it with the mode multiple command. Okay, this command will change the behavior of the device, will initiate a reboot. hit enter, convert the configuration, and it will go into a reboot. Okay. Now, when it comes back up, we should now have that context command available. Now we should be able to do any context-based configuration.
Sir, so after changing the context, we have rebooted the ASA?
It needs to be rebooted, yes.
Okay, so it would take the effect, right?
Right. It's kind of like a mandate step.
Okay.
Okay, so it kind of tells you to. So I didn't put in the reboot command, but when I entered that, it actually did mention here. Okay, this command will initiate a reboot.
Okay.
So it's kind of like a mandatory step.
Okay.
So anytime you change any sort of modes, if you remember when we did the transparent firewall, okay, we changed the mode from routed to transparent. That's when a reboot was required as well. So anytime you change a mode, a reboot is kind of required to enforce it or get the change into effect. Okay, so it changes. Right now, I am kind of in a console connection, okay, which means basically I'm connected to the system space. Okay, I changed the mode, and if you're going to see here, it basically created an admin context for me automatically. Okay, so it automatically created a admin context for me. If I do show context, you can see an admin context has already been created for me. And you can see where that config is being stored. Okay, so the config related to the admin context is stored in the disk 0, and this is the file. If I do directory, it will show me the contents of the disk 0, and this is where my admin CFG is. Okay. If for some reason, or if any version, it does not create the admin context for you, that's the first step that you're going to do, creating an admin context. So you can come in and you can do admin context and give it a name. That's all that you need to configure, okay, to create your admin context. That's the first thing that you're going to do. If it does not create it for you, for me, it did created it automatically. Here, I didn't really have to do it. Okay, and the kind of reason it does that is once you are the console, you are bringing up a new chassis, a new device. Obviously, you won't be on the console forever, right? You would want to be connected to something like a telnet or an SSH, maybe ASDM via HTTPS, okay? And whenever you connect through the telnet or SSH, you connect to an admin context, okay? So if an admin context is not present, then you'll face issues in that connectivity. So that's why it kind of gives you that automatically. Let me just delete this. Okay. Now let's create our customer context or user context. Say context C1. Okay, created that context for me. Next thing is putting that config URL. So I'm going to say config URL disk 0, and I'm going to say c1.text. That's where I want to store the configuration for this context. Okay, it could not fetch the file, so that file was not already present in there. It basically created the context with default. Okay, the next step is allocating the interfaces. So one interface that I want to allocate is ETH0. I'm going to do an allocate interface, E0. And another interface that I want to assign this is E1, this guy here. Okay. If I do show context, we now have our C1. It has two interfaces that are configured, and this is where the configuration is being stored. Okay. Next, we configure the second context. Context C2, and name can be anything. Okay. So this can be anything. It's just a word. Okay. So maybe if you have a customer, right, you can give it a customer name so that whenever you are viewing the configuration, you actually have a better idea what's that context is really for. So context C2. Same thing, config URL, say disk 0, c2.txt. Okay. And you're going to allocate the interface. Now, another good thing that you can do is you can also hide the interfaces from the customer. And when I say hide the interfaces, if you are in kind of like a managed service provider kind of environment, you might not want the customers to actually see the actual interface numbers. Okay. So you can hide the interface number so that the customer only sees a name for it. Okay. So you can do something like allocate interface. And one interface that I'm going to allocate is E0. This is going to be the shared interface. Allocate interface E0. Okay. And another interface that I'm going to allocate is E2, right? But I don't want them to see the number. So let me just name it C2 inside. Okay. So now this customer is not going to see only the C2. The C1 will be able to see is interface E1. But when the C2 checks its configuration on its context, he will not see the actual interface number. He'll only see the name. And I'll show it to you. Okay. Show context again. We have two contexts here. This is the shared interface. Okay. And these are our respective interfaces. Now, you can also limit the number of resources that each context gets. So by default, all of them are part of this default class. Okay. If I do a show run class, this is the default class. Okay. So by default, every context gets these resources. Okay. So you cannot limit the CPU resources. Okay, so you cannot see, hey, this guy gets 2 virtual CPUs, this guy gets 2 virtual CPUs, this guy gets 4 cores. You cannot do that. Okay, but in essence, you can control the number of SSH connections, telnet connections, the number of MAC addresses, these sort of things. Okay, so these are the things that you can limit. So what you can do is you can create an own class. Let's say I can say class, let's say diamond. Okay, name can be anything. Okay, so this can be any word, any name. Okay, let's just say diamond. And if I do limit resource, you have a lot of these options that you can provide. You can also configure a rate. How many connections you want to limit per second? Inspections, maybe syslogs, okay, connections, hosts, routes in the table entry. Okay, so through this, you can control the amount of resources that a particular context is going to consume. So for example, I'm going to say I'm going to limit the rate to connections, let's say 1,000 per second. Cons 1,000. Okay, so this is a class that we created. We can now go into any of our context and add it to that class, member daemon.
So can we maximize this window?
This one?
Yeah, this. Yeah, thank you.
Okay, if I do show context, the C2 context is now part of that daemon class. Okay, which is what we created here. So through the class configuration, you can basically limit the amount of resources, and limiting the amount of resources directly, you cannot influence your RAM or your memory or your hard disk or your CPU, but the actual resources which are going to consume the memory and the CPU, those are the ones that you can control. Okay, and by default, so you won't find this configuration in a single context mode. Okay, so if you are running in a single context mode, you won't have this. Once you convert the ASA into a multi-context, that is the only time that you will be able to see this. Okay. And by
yes, sir. Sorry to
yes,
interrupt.
yes,
So
yes.
in this scenario, so have we limited the resources to 100 connections? 2,000
connections per second.
Sorry, 1,000 connections, right?
Right.
Okay.
And I've applied this to this one context.
Okay.
And so there's one more query. The MAC address which is mentioned, 65535 is the MAC address. Means per system user can up to this much we can allow in the single context zone, or it is how is it?
Right.
Okay.
The maximum number of MAC addresses that you're going to allow for any context is 65,535, which is a lot, right?
Mm-hmm.
Yes.
So yes, you can manipulate these. So everyone gets these by default. Okay. And yes, you would want to limit them on a per customer basis. Okay. Now we have our context created. Now let's say, let's go into and move into or jump into a context. So you can jump into context with the change to command. I can do change to C1. Okay, change to context C1. Okay, so we are now in the C1 context. If you do show interface, we're going to see it has the two interfaces that we assigned it to. Or if I do show run, you can see it has only two interfaces. And the host name is already assigned it saying C1. Okay, it's just a regular firewall now. Okay, so here it's just a regular firewall. It's virtualized, but it's the same firewall, right? So all the things that we have learned about, your MPF, your inspection, and all these commands and everything, they need to have a name if, need to have a security level IP address. All of those concepts apply as it is. There's no difference. Okay, so let's configure this. C1 context, okay. So the outside interface here, it basically gets a .1, right? So on C1, we do interface E0. And I'm going to say name if outside. It gets a security level of 0. Say IP address 10.123.0.1, 255.255.0. And do a no shut. Okay. Next, we have the interface E1. We're going to say name if as inside. I'm going to give it an IP address of 10.10.10.1 and do a no shot. Okay. And we want to test with ICMP and everything. So we need to enable the ICMP inspection as well. So I'll just run fix a protocol ICMP. Okay. And this should get added to my ICMP inspection. Okay. Same principle, same concept. By default, ICMP inspection is not enabled. Add the ICMP inspection so that we can do some testing and check out our ICMP. Okay. If you do show run, you can see our configuration. Okay. Do show interface IP brief. One thing to note is that the interfaces are down. And the reason for this is in the admin context, we did not unshut the interfaces. Right now, we are in the virtual context, right? So even though I did a no shut, both the interfaces, it does not take effect because we are not in the system space or we are not in the admin context. Okay, so this is a very common thing that is often missed, right? And you would keep scratching your head because it does not tell you that it's administratively down, right? Typically on devices such as routers or even switches or any other device, if you have a shutdown command specifically entered under the interface, the status basically mentions administratively down. You don't see that here, okay? So that can add to the confusion if you're not aware that you need to enable those interfaces in the system context or the admin context. Sorry, the system space or the admin context. Okay, so let's first do that. I'm going to do a change to context and I can just do system. And I'll come back into the system context. Here, I need to enable all of my interfaces. No configuration. I just need to unshut those interfaces. Okay. Unshut all of them. Right. We're not using 3, so I'll just let it be. Okay. Right. Let's go into context again. Should now have both of these interfaces up and working. All right. So that's my context 1. Let's jump into the second context. C2. See the name. So from a customer's perspective, who's just logged into this context, he does not know what interfaces are available to him as far as the number is concerned. Okay, so he does not know whether he gets Ethernet 0, Ethernet 1, Ethernet 2, Ethernet 3, maybe gig Ethernet 0, 1, whatever. Okay, he only sees the name. That's it. Okay, and when you're trying to do something like that, make sure you give it a meaningful name. Okay, so for example, the C2 inside. So from the customer's perspective, I can let the customer know, hey, we have assigned you this context. These are the interfaces, the names govern how your networks are. So if it says inside, it means it's for your trusted network. If it says outside, it's for your outside network. So make sure if you're trying to hide this, you're trying to give it a name, make sure it's a little bit meaningful for the customer as well. Okay. Let's configure this. So interface E0, shared interface. And obviously, I won't be able to give it the same IP because it conflicts with context 1. So it can be in the same subnet, but it cannot be the same IP address, obviously. right? So my subnet can be the same, but the IP address cannot be the same, right? So I'll give it a .2. Same thing, name if outside, right? And yeah, that's it. Then E2 here, interface. We need to give the name. So C2 inside. IP address. This should be in a 10.20.20.2. Is it .1? Okay. Name if inside. It's already unshut. If I do show interface, IP brief, we have our IP addressing, we have our connectivity, right? So from here, we should be able to ping this outside area here. We should be able to ping the router. Okay, that reachability should be there, obviously. And I'll also do fix a protocol ICMP so that we can do some ICMP testing. Right. So that's your context configuration, basically. Now, the next set of and the shared interface issue that I want to show you is this is a shared interface, right? So both of those contexts are using that same physical interface. So it's the same MAC address for both the contexts right now. Okay. So if this guy tries to reach out to edge router, it will be using the 10.10.10.1, which will be context C1. When he pings, his default gateway will be 10.20.20.1, which will be context 2, right? So both of them come in and then they leave through the same physical interface. From this router's perspective, the confusion would be where to send the traffic to. Okay, and we'll see that. So let me just configure the IP address, right? So if you have ever worked with EVNG, so these are just virtual PCs, okay, very lightweight devices. You can give them IP address, they support ping, DHCP, and everything, okay? So very good for doing some very lightweight testing. We'll give it an IP address. Let me just see what the format is. Okay, IP 10.10.10.100. Mask is this, and 10.10.10.1 is the gateway. So this is my PC1. Okay. It's in VLAN 10.10.10.1. We should be able to ping 10.10.10.1, which is our C1 security context, which has the Ethernet 1 interface. Okay, let me just bring this. Too many windows. Let me just bring it here. Better. Let's do the same thing for C2. Sorry, PC2, not C2. Okay, I'll bring this in here as well. Right, so this will be 10.20.20.200, 255.0, 10.20.20.1. Okay, so both of them have reachability. Both of them can reach their respective gateways, which is basically their respective context. Now from here, let's try pinging all the way up until this device here. So I do a ping 10.123.0.254. ping 10.123.0.254. Okay. So none of them have that reachability. If we come back on the ASA here, if I do show log, so that's my Ethernet 0. This is the MAC address that it has. Okay. So MAC address, and we are in context C1. Now we are in context C2. Okay, so same MAC address throughout. If you come in here to this router here, so from the router's perspective, it is receiving traffic from two different IP addresses, and this one was context C1, context C2. Both of them are with the same MAC address. Okay, so two different traffic going to two different contexts, but same MAC address. So that's where the problem comes in, that there is no reachability, obviously. Okay. So how to fix it? Obviously, one of the methods that I told you was to basically go into individual context. Okay, and you can configure the MAC address, right? So for example, like I'm in C2, go into E0 and use the MAC address command and configure a MAC address. Okay, too tedious. Maybe if I have 50 context, I have maybe 20 firewalls that I manage. Obviously, if I'm a service provider and MSSP, I would have a bunch of different devices. This is too tedious work, too much work. Okay, and then MAC addresses will have to be unique, obviously. So better option is to enable the automatic generation. So you do MAC address and auto generate MAC address for context interface. Okay, if you do a show run, this is we are in the system space. Okay, I'll show that command. There it is. Right. The physical interface still has the same MAC address. Okay, that does not get changed. Look at the MAC address now. That's context C1 for the E0 interface. On C2, it's completely different MAC address. Okay. It will basically change the MAC address for every single interface that's part of the context, not just the shared interface. Okay, so that command is doing a global generation of automatic generation of MAC addresses. You're not defining within the command that, hey, generate the MAC address for only the shared interface. You're not doing that. Okay, so on the C2 interface, the E1 interface, right? Sorry, the E2 interface that we define with the C2 inside, it also has a different MAC address. Okay, if we check system, C2 got Ethernet 2. This is the actual MAC address for that physical interface. But due to the automatic generation, it has a completely different MAC address now. Okay. So this should be a completely different issue now. Okay. And the issue would be that this firewall does not have a route back. So if I do a show IP Ceph and we're trying to reach
So the
10.100.
The timeout is due to the MAC address was same, or it is due to routing problem?
The MAC address being the same.
Okay.
Right? So when the traffic is coming to the ASA, from the ASA's perspective, it does not know which context it should select.
Okay.
Right? Because the destination is the MAC address, the interface itself, right? So it cannot differentiate between where the traffic needs to be sent out to. Okay. So this issue is, it does not have a route. So let me just quickly add a static route real quick. And I'm going to say 10.123.0.1. My bad. Just a second. What is it? 123.0.1. Let's just do this. Let's do 10.10.10.0. 255. Yeah, I use the wildcard mask. 255.
That's what I
Right?
was thinking. Why you use the wildcard?
I'm doing a lot of security nowadays. So I do a lot of access lists and those sort of things. So, you kind of get that habit of doing all the wildcard masks.
Yeah, I got it.
Right? So now there should be reachability here. And same thing, we should have reachability from the PC2 as well. Okay, that's fine. We can see why that's not working. But the main agenda is that now we should have those different MAC addresses there. Okay, so that's the only problem that you're going to face if you're trying to do any sort of shared interface. Okay, that's the only problem that you're going to face. Apart from that, there is no issues with using security context. Okay, and now you know how to resolve it as well. So it can help you with troubleshooting if any of that issue comes up as well in the future. Okay. So any questions related to context or this issue with shared interface?
We can also restrict the MAC address, right? Like if we, hello?
Yes.
Yeah. So like if C2 customer from outside, and we don't know how much they are there, but if we consider this much of MAC address is required to hit to the
right. So let's say it's a small customer. He only has about maybe 50 to 80 devices. You can restrict or limit the resources to only 100 MAC addresses.
Okay.
Right, and you do it through that same class configuration that I showed you before.
Okay. So that was the 1,000 connection. So we can limit the rate with the
not the connection. Okay. So if I do class, so you have this limit resource MAC addresses. Okay. So it's by default set to the total number of ports that are there, right? For some reason, so you can set it to 100.
Okay.
Okay. Okay. Now, within the realm of security context, you can also have your high availability, right? So you can have, or I can have this device here act as a standby device, right? So this device is, again, it is completely blank, right? So there's no configuration at all. It's completely empty. It's a fresh device. Okay, so no configuration has been done. So let's configure a high availability between these two. Okay, and we will make this as the primary, this as the secondary. This link here, this will act as the failover link. So it will do two things. It will act as a failover, which will be responsible for a configuration replication. Okay, it will be responsible for those heartbeats. Okay, and it will also behave as a stateful failover link. When I say stateful failover, all of my stateful tables, my connection table, my NAT table, my VPN, my dynamic routing protocol entries, my VPN connections, all of that needs to be replicated to the standby as well. Because if this guy fails and there are about 100 connections going on, I need to maintain those connections. I need to have that statefulness maintained. Okay, so if the standby device does not have knowledge about those stateful tables, as soon as the standby comes online, it becomes active, all of those connections will be dropped. Okay, so this link is serving two purposes. It's doing the configuration replication, and it's responsible for exchanging the heartbeats between the units, and it's also responsible for that stateful table or that stateful data replication.
What is the query here regarding this link? So is it like as you in a lab, you used single link, right, to form
Right.
a HF? So in real scenario, how much connectivity we can use to form a HF?
You can have two links. You can dedicate one for failover, one for stateful. But in 99% of the deployments, you use just a single link. Okay, so that single link can do both absolutely fine. There's no issues with that. Okay, but if you have more interfaces, let's say you have some interfaces that are not being used on both of these ASAs, because again, they use physical interfaces. So if you're using two interfaces, you are basically subtracting two interfaces which you cannot use for anything else, for any of your data traffic.
Right.
Okay, so typically that's how in deployments, in production, you're going to do it. Use just a single interface. It's absolutely fine. There's no problem with it.
Okay.
Okay, and the configuration is also pretty straightforward. Okay.
So that's a layer 2 connectivity, right? So
that's a layer 2 only, yes.
But you have mentioned IP address and everything.
That's just a logical IP addressing that's configured. So the IP addressing is configured, but it's in the same subnet. There is no routing that's coming into play here. Okay. Even if I have IP addressing, but it's a pure layer 2 connectivity. There's no layer 3. When I say layer 3, there's no layer 3, I mean there's no routing. Okay.
Got it. So it is just like how we are connected to PC with a single Ethernet cable.
Correct.
To data transfer. Okay.
Right. Okay. And there can be no routing in between two. I cannot have this link connected to a router and then connected here, or to another router and then connected to this. So there can be no routing in between.
I think this concept is being used in many domain, like in voice. We have SBC devices, VoIP SBC devices. They're the same scenario. They are to form HA. They are using the layer 2, or almost they're using the same cable between two layers, which will directly connect to each other.
Right. Right. Correct. Okay. So let's set up our high availability pair. So by default, failover is disabled. So if I do show failover, the failover is disabled by default. Okay. And by default, any ASA is a secondary unit. Okay. This is going to be a primary, so we'll have to specifically mention that failover LAN unit primary. That's the first command, which makes this unit as the primary unit. Next is we're going to tell what that interface is going to be, which is going to be used for failover. In our case, it will be the Ethernet 3 interface. So we're going to say failover LAN interface. We're going to give it a name. I'm going to call it FO, failover.
It
And
was
then we're
showing failover unit secondary, and we are making it as a primary.
Right. So we are going to make this as a primary, and then we will keep this one as a secondary.
Okay.
Okay. So failover LAN interface FOE3. And before I do this, if I show you the configuration, okay, it's shut down. So I'll just enable it. That needs to be done. And there is no other configuration. Okay. Failover LAN interface. We name it FO or failover E3. When we configure an interface as a failover interface, all the non-failover configuration will be cleared. Okay, so if I check that configuration again, it would have basically added a description as well. Okay, previously there was nothing on this interface, and now it added a description saying, hey, it's a failover interface. All right. Next, we're going to give it an IP address. Failover interface IP, the name that we configured FO, and we're going to give it an IP address. 172.16.16.1. Subnet mask. And we are also going to mention what the IP address will be on this standby device as well. Okay. .2. So whatever standby IP is, it goes to the standby or the secondary ASIC.
So Arun sir, with this command, we are stating that the second device will be physically, it is in standby, right? It's not logic, physically standby.
Right, physically standby, logically standby as well. So once this comes up as the primary, it will also become the active device.
Okay.
And this one will become the secondary and the standby. Okay.
Thank you.
Standby. And the next thing that we're going to do is we're going to mention what the stateful link is going to be. So failover link FO ETH03. So here we configured failover LAN interface. Here we're configuring failover link. The difference between the two is this is your actual failover, which basically means configure replication and heartbeats. When you say link, this is basically your stateful data. Okay, so here I could have mentioned a different interface as well, right? But since we are using the same interface for both, I'm going to mention E3 here as well. Okay, so that's the difference. It's link and LAN. So LAN means failover, and link means the stateful link or the stateful data replication. Okay. And the last thing is to enable failover. Very important, right? So don't forget to do that. So failover is still disabled. We need to enable it with the failover command. All right. So now we have this enabled. Now we need to configure the standby as well. And I'm going to copy these commands and just paste it as it is on the standby. These 3 commands only. The similarity is Ethernet 3 is also there on the ASA standby or secondary. We have both the LAN and the link, the same configuration as the primary on the standby as well. But we want this device to be the secondary. So that's why we are not copying the primary command. Okay, so by default, this is already secondary, and we want it to be secondary. So we'll copy these 3 commands. And it's basically trying to look for a mate, a device, okay, which is basically 172.16.16.2. Okay, so it's actively trying to look for that active device, active mate. So let's copy this. And before we paste it, I'm going to enable that Ethernet interface, no shot. And we're going to paste here. Okay. And don't forget to enable failover. Right? So see what it says. The mate's operating mode is multi, is not compatible with my mode, which is single. Right? So this is basically in a multi-context mode. This is in a single mode. So if you're trying to bring in a context-based device, right, you need to first switch that context. Okay. So let's do that. So I'm going to say no failover. I'll disable the failover for now. Right. And I'm going to say mode multi. Have it reboot. And once it comes back up, we already have the configuration. I don't know if it saved the configuration or not. We'll check that. Okay. So once it comes back up, we're going to copy this command again. And okay. So typically the ASAs are quite informative in what really is the problem. Okay. And since I'm on the console as well, so I do get these console warning messages, informational messages as well. Okay. Let it just boot up, come back online.
Arun sir, yesterday actually I was trying to do a netting lab on my AVNG. So I got error like asymmetric NAT suspected. I got this error. What do you mean by this asymmetric path reverse in netting?
Was it an RPC check failed?
Yes, sir, yes, 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 right, RPC.
Okay. So it could be. So not sure what the setup is and everything. So were you trying to do destination NAT?
Yes, destination or yes.
So you're
towards
trying
outside.
to, yeah. So you're from the outside, you're trying to come in.
Yeah, right, exactly,
Right.
right.
Okay. Yeah.
Right.
So that's a very common issue that happens. So you have an ASA. This is
Yes.
someone on the outside, right? This is basically, let's say, your DMZ server, right? What was the IP address for the DMZ server?
10.1.30.2.
Okay. And what's the IP address for this user who's trying to access?
172.16.10.2.
And what's the IP address for this interface?
It's a 20.1.1.1.
Okay, so now when you were trying to access, what was the IP address that you were trying to access? This one?
Yes, from outside. Yeah, right.
Right. So it will fail.
Okay.
Okay, so what is happening is, so there are a couple of things. What the firewalls and mostly routers as well, they are configured by default. They are protected against IP spoofing.
Okay.
What this means is this link here, this link cannot allow any traffic which is in a network other than this network.
Okay.
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 So imagine if someone is on the outside and he's trying to be on 10.130.1, right? This is maybe an attacker.
Okay.
Right? From the firewall's perspective, the firewall might think, hey, this guy is also on the inside here.
Right.
Right? So I allow this traffic.
Okay.
Right? So this is to protect against IP spoofing. So anytime this traffic needs to be in this network only then it will allow it. Okay. So in this scenario, what needs to be done is, irrespective of the fact what this device is, so it can be in any IP address, this user, whoever is trying to access, right? What you would want to do is this DMZ server, it will have, just imagine it has a public IP.
So I use the mapped IP is 20.1.1.15.
1.15, yes. So this device needs to access 21.1.15.
Okay. Okay.
On the ASA, you will have a static NAT which says, hey, 21.1.15 NATs to, or translates to 10.1.30.2.
Yes.
Okay, so that's what you need to configure.
Okay. So yes. So I think in netting I use the when I configure the NAT, DMZ outside, and the destination was 20.1.150. So when I was doing a so XLAT, I was able to see that natting mapping XLAT was perfect, but I was so when from outside when I'm trying to do a telnet, that was I'm getting the this error message.
So do you have, so did you configure an access list?
Yes, access list from outside. Yes, I configure a access list with
Configure an access list. So what was the IP address that you configured for the
So-
destination? Was it this or was it this?
no, I think I used 10.1.32.
Okay. So if you use this IP address, then that's correct.
Okay. Yes, sir. So
Okay.
I use this IP address, and when I was doing a so XLAT, the translation was showing correctly, but so as you said, while doing a telnet from outside, I was getting the asymmetric RPC error.
Right. So that is one issue that I mentioned. Just look back again, just go in and do just repeat the configuration, just take it slowly, just see what you're trying to do. If you've configured the IP addressing and the policies and everything correctly, just try to do that. And if it still does not work, then let me know. Okay, we can look into it why it's not working.
Sure, sure.
Okay.
Thank you.
And
Thank you.
we can even maybe just run through it in our lab as well if it still does not work, and I'll show you how and why it won't work, and what maybe you might be missing.
Okay, sir. Thank you.
Okay, just try it again. So this concept is clear for the IP spoofing, right?
Yes, yes.
Okay.
So Arun sir, the external user is in a different, how can it be a same network, sir? You said like,
Okay, so we are just trying to simulate. So just imagine, so in real world, this would be your internet. Right? This user can be anywhere.
Yeah, definitely.
Right? So this ASA will be connected to your ISP's router. So the ISP is going to be the one who's going to forward that over this link. Right? So here we're just trying to simulate that, hey, this is a user directly connected and he directly needs to access this IP address, but it can be any user on the outside. Okay, and he could be configuring any IP address, but this would be a public address that he accesses from the outside. Okay, and it will be the responsibility of obviously how the routing will work. So this link will be connected to your ISP, okay? And when the traffic will come in here, obviously it will be in this same subnet kind of. Okay, so in the lab, we're just trying to simulate, right? We're just trying to simulate that, hey, this is a user on the outside. We're just trying to see how the ASA is going to behave and how the natting and unnatting basically happens.
Answer I will do, and
Yeah, sure. Just do it. Just go over it once, and then let me know in the next class. We can discuss. And if it still does not work, then we'll quickly spin it up in our lab and see what might be going wrong. All right.
okay. Thank you, sir.
Okay. Right. So coming back to our thing here, it's now in multiple mode. Let's check if we have the configuration. It has the configuration. Okay. Let's enable failover now. Zero with 3. Okay. Still failover. Still failover here. Beginning configuration replication, sending to mate, configuration replication ended. If you come on the standby, detected an active mate, configuration replication, it created C1, created C2, right? So whatever configuration was on here, it created that same configuration. If we do a show failover now, we should see this host is the primary active. The other host is secondary. It's standby ready. And if you're going to see C1 has 2 interfaces, C2 has 2 interfaces, outside, inside, and you see something as unknown waiting here, right? The thing is, because we never configured those standby IP addresses. When I say standby IP addresses, we configure this for the failover link. We also need to configure standby IP address for these interfaces as well. As you can see right now, the interfaces don't have an IP address on the secondary device. So what needs to be done is, and I covered this in the last class as well, the last weekend class where we did the active standby. We will go into our individual contexts. Let's first start with C1. And we need to configure those interfaces. Interface E0, I'm going to say no IP address. And I'm going to say IP address 10.123.0.1, 255.255.0, standby 10.123.0.2. Okay, so every configuration needs to be done from the primary or the active device. Okay, so .2 is already configured on that. So let's say, let's say 11. Okay. Phase E1, say no IP address. I'm going to say IP address 10.10.10.1, 255.255.0, standby 10.10.10.11. Okay. Now we're going to move into our C2 context. Interface E0. Let's do no IP address. IP address 10.123.0.2, 255.255.255.0. Standby 10.123.0.22. Just configure that way. Interface C2 inside. Say no IP address. I'm going to say IP address 10.20.20. It's 22. Sorry, 10.20.20.1, 255.255.0. Anything configured with the standby command that gets configured on the standby unit or on the standby firewall. Okay. Okay, so these IP addresses now get configured on the secondary as well. Okay. So this is, so a couple of things, again, this is the primary unit. This is the interface, which is being used for LAN. It says active. This is our version. This is the version of the mate, which is the standby. At the bottom here, this is your stateful table. Okay, things like your TCP connection, UDP connection, ARP tables, VPN tables, your routing sessions, things like VPN tables, and all of this. This is also being exchanged, okay, with the standby. Okay, if I come in here, so right now, if you're going to see prompt here, and look at the prompt here, and we are on secondary, and look at the prompt here, right? So it can be confusing. Which device are we on? Whether we are on primary, whether we are on secondary, both of them are showing primary, right? That's because whichever device is kind of active, that is what you're going to be seeing the prompt for. Okay. And I told you a little trick to fix that is to change the prompt. Okay. You can do prompt, and I want to see the host name, right? Maybe I want to see the priority and the state as well. This is very helpful. Specifically shows the host name, what's the priority is. Right now, this is the primary, and I am on the active device. So this configuration would have been replicated on the standby, right? Now, when I hit enter, look at the prompt.
Will show failover or show version will show this device is a primary or secondary.
That will show it as well, yes. But when you're kind of logging in, this prompt really helps to see what you are on.
Yeah.
So if I do this, it says secondary and it says standby. Okay, so nice little trick, a really helpful tip for production as well. Okay. Okay, if I do show context, so all of that configuration has been replicated. Another thing that you can do is, because anytime you're in production or anywhere, you would be logging into the primary or the active device only. Okay, you can run some commands. So you can do something like failover exec, and I want to run this command on the mate. And I want to see show interface IP brief. So now this command is being run on the standby device on the mate. Similarly, I can do show name if maybe. Okay, that won't work. Show run. So this is now being run on the other device. Okay. Show version, you do show failover. This is the standby ready host. The other one is active. Okay. So this is basically, again, your active standby. Now, the problem with this is still not a pure active, right? Right? Why? Because this is active. Both the contexts are active on a single firewall. And both these contexts are standby. So we are still in the situation where this is going to take all the traffic for now, and this will keep in standby. Only if this device fails, this will become active. Right? This will become active. And both the contexts will be taking the traffic on this firewall. Okay. So to achieve kind of like an active failover, we need to make use of failover groups, right? So let's see our failover groups. And you're always going to be on the primary or the active device. That's the only place where you do the configuration from. Okay. First thing is we're going to enable failover, or basically I'm going to configure failover. So we're going to configure failover group 1. Okay, so do failover. You have an option to configure group. Okay, so failover group 1. Okay, so let me just disable failover. Just do no failover here. Not from here. Just do no failover. Right, so I disable failover, right? So look at the state that it's currently in. It will stay inactive and no failover. So if I disable failover on the primary, it does not mean that the firewalls will switch. Okay, this device still stays active. This device will stay in standby. This unit is currently in standby state. By disabling failover, this unit will remain in standby state. This is again very different from other devices that you might have seen. If you disable failover on one device, the other one fails over, switches over to active because it stops receiving heartbeats from the other device. It's not the case with ASA. And this is specifically meant to prevent split brain. Okay, where both the devices think they are active and they're trying to repeatedly take the active role. Okay, so within an ASA deployment, it is typically very difficult to get into a split brain state. If both the units cannot verify, or if there is no reachability between those two units, both the units will remain in whatever current state they were in. So this guy was in standby, it remains in standby, it does not switch over. And this guy is in active state, it remains in active state. Okay, so very important. Now let's configure our failover. Failover group 1. I'm going to say preempt. Allow preemption of lower priority active unit. Okay. And I'm going to say primary. So failover group 1 will be active on primary. I'm going to go into context C1, say join failover group 1. Same thing, I'm going to do failover group 2. Preempt for this as well. Okay, and I'm going to say context C2, join failover group 2. Okay, so what I'm saying is context 1 is going to be active. So now we are trying to achieve active-active failover. Okay, what I have configured is I've configured failover group 1 and failover group 2. I'm saying failover group 1 is active here. And failover group 2 is active here. I'm saying C1 is active here and C2 is on standby. And here I'm saying C2 is active and C1 is standby. Right? Previously, what was the thing? C1 was active here, C2 was active here. C1 was standby here, and C2 was standby here. Right? So this was with active standby. You can see the difference. Now, one context is active on one, and the second context or other context is active on the other firewall. So both the firewalls can now actively take traffic. Okay.
We created the failover group, but where it should be active, have we mentioned is that?
Mm-hmm.
In which firewall the group should be active?
So failover group 1
okay.
needs to be active on primary.
Primary, okay.
We configure failover group 2, and we mentioned, we didn't mention secondary, but I should do that. Failover group 2, I'm going to say secondary. Okay. Now I'm going to re-enable failover. As soon as I enable failover, this becomes active again. From no failover, it switches again to active. And we did some configuration changes. We made the failover groups, so that configuration needs to be replicated to the mate as well. If you come to standby, we can see the configuration is being replicated. Okay, group 1, group 2 detected, group 2 preempt mate, okay. So let's do show failover. Now you see a very different output, right? You have group 1, which is active here. Group 2 is standby, right? So what was in group 1? Group 1 was in C1 context. Group 2 was in C2 context. So on this device, on this host, we have active standby here. And on the secondary, the group 1, which is context 1, went into standby, and group 2, which was context C2, is active. A better option is, or a better output to see the failover group is to do a show failover group 1. Okay. So for failover group 1, this is active. C1 context. And standby is the secondary device for C1. Similarly, for failover group 2, I am standby, but the other guy is active. Okay, so this is a much better output to see the failover groups. And there's also no need to have the MAC address command. Let me just see. I'll remove the MAC address auto. Okay. Right, so there's no MAC address auto. Let's go into context C1. Let's do, right, so let's do show interface E0. There is automatic ASA. So ASA generates the MAC address automatically without the need for that MAC address auto command. So if you're trying to do active-active failover with your security context, you basically don't even need to worry about the MAC address causing an issue on your shared interfaces. Okay, and that's only thing that should be configured from the failover perspective. You can now configure the firewall as you would like. Okay, it's typically just your regular firewall. It will do everything that firewall does. It's just that you are now doing active-active failover. Okay. Any questions?
Yes, sir. So this is a auto failover, right? This configuration helps in auto failover, right?
Right.
So in case for some reason the auto failover is not working, and if we have to do a manual failover, so do we straight away go to the interface and shut it down, or is there any other method, alternate method for that?
When you say failover does not work, what do you mean by that?
Like for some reason the auto switching, the auto failover is not happening from example from EA Ethernet 0 to Ethernet 1 for some case, for some reason. And in this scenario, if one link is down, for example, the traffic is not going through the Ethernet 0, and the failover is not working, in this scenario, should we go for a manual failover? And how does that work?
It should fail over on its own. So as long as it can detect which device is healthy, whether I am healthy or whether the other mate is healthy, depending upon that, it should be able to fail over. If for whatever reason it does not fail over, okay, the first thing that you need to make sure is that your connectivity is there. Okay. You need to make sure that this failover link is not down for whatever reason. Okay. There is no issue on this failover link, because you don't want to force the failover and then cause a split brain. Okay. So you need to make sure that this connectivity is not affected due to whatever reason. Okay.
Okay.
And you need to make sure that these interfaces here, they are also functioning, the links are functioning perfectly fine. Okay. And if you're sure that nothing in your network is wrong, and there might be an issue with maybe the ASA code or something, okay, there might be an issue with maybe a process being stuck, could be anything, right?
Yeah.
In that case, you could force a failover, okay, and you can come in here, do a failover. Let me see what the command is. So you can do, you can force a failover. Come in here, let's do failover active. Okay, so you can go to the standby and say failover active. So this will make the system to be the active unit.
Okay.
Okay.
So
and
so
if
in
you
this
want,
case,
yes,
yeah, please go ahead, sir. So
and
in
if,
this, sorry. So in
Go
this
ahead, go ahead,
case, so in this case, this firewall acts as a primary one, right?
right,
If once it has been moved to active, when we
Right.
force it to active.
correct. So you make, so
Okay.
we can make this unit active. And
Mhm.
if maybe for some reason your standby is not functional, it's not responding, then from the active, you can also reload the standby.
Okay.
Okay. Or you can force a unit if it's in an unfailed state. So
Okay.
maybe if this is stuck for some reason, you can come in over, you can do a failover reset. Okay, which kind of resets the process. So
Okay.
a couple of these options that you have that you can make use of.
Okay. Okay.
If things
Thank you, sir.
don't automatically work out.
Yeah, I do
Okay.
understand. Thank you, sir.